Today we're going to be talking about properties of parallelograms. So we're going to look at some vocab first and then look at the properties that go along with those vocab words. So the parallelogram is a quadrilateral with both pairs of opposite sides being parallel. That's what makes it a parallelogram. And it has opposite sides. So opposite sides are the sides that don't share a vertex. So opposite sides would be AC, BD, and then AB and CD. Those would be pairs of opposite sides. And opposite angles do not share a side. So A and D would be opposite angles, and C and B would be opposite angles. And then consecutive angles do share a side. So if we look here, A and B share a side AB, so those would be consecutive angles. B and D share side BD, so those would be consecutive angles. C and D share side CD, so those would be consecutive. And then A and C share side AC, so those would be consecutive angles as well. So we're going to take some look at some properties that go along with parallelograms. Now, you don't have to memorize the theorems, but you do have to know the properties. So if you're given a parallelogram, which we are given over here, we can say that the opposite sides are congruent. So we can say that AB is congruent to CD and that AC is congruent to BD. The next one is if you're given a parallelogram, then you can say that the consecutive angles are supplementary. So remember, consecutive angles are the ones that are next to each other. So A and B, those would be supplementary, and supplementary means equals 180. So if you add them together, they equal 180. And then the next one is if you're given a parallelogram, then the opposite angles are congruent. So angle A and angle D are congruent, as well as angle B and angle C are congruent. And again, if you're given a parallelogram, then you are given diagonals that bisect each other. So remember, bisect means they cut each other in half. So they'll cross here in the middle at point E, and then they'll be cut in half. So then you get AE is going to be congruent to DE, and CE will be congruent to BE. And the last one is if you have 3 or more parallel lines cut off congruent segments on one transversal, then they cut off a congruent segment on every transversal. And so in simpler terms, we're used to having 2 sets of parallel lines, and now we're going to have 3 or more. So what you have to be given is over here on the left-hand side, you have to be given more than 2 parallel lines, and then you have to be given parallel or congruent transversals here that are cut by those parallel lines. So if you're not given that, then this does not apply. But if you are given that, then what you can say is that any other transversal that goes through, so this transversal also goes through those 3 parallel lines, it's going to create those congruent segments like BD and DF. So we're going to look at some example problems with these theorems, and we're going to have to use the theorems and what they mean to help us solve the problems. So if we look here first at number 1, we have this parallelogram, and what we're given is we're given this angle here and this angle here. Those are consecutive angles. And so what we just learned about consecutive angles in a parallelogram is that they are supplementary. So they're going to equal 180 degrees. So I'm going to set up my equation, set them equal to 180 degrees, and then solve for x. So then x will equal 71. So I have to use what I know from the theorem to set up my equation. Now for number 2, I know that these 2 angles here are opposite. And I know from the theorem that if I have a parallelogram, opposite angles are congruent. So if this is 58, then x also has to be 58. Now for number 3, I'm given a parallelogram and I'm given 2 sides, 2 opposite sides. And what I know from my theorems is that the opposite sides are congruent. So I'm going to just set up my equation. Now congruent is the same as equal, so I'm going to set them equal to each other. And then I'm going to solve for x. I'm doing the inverse sign every time that I flip over the equal sign. and I get x equals 5. Now, if it asked me to find a side, I'd have to plug x back in, but it just wanted x. Now, over here for number 4, I'm going to look at the picture, and what I have is I have the diagonals that are crossing, and again, from the theorems, we know that the diagonals bisect each other. So with that, I'm going to cut them in half, so that means that they're equal. So I'm going to set them equal to each other. So I'm going to do 5x plus 2 equals 4x plus 6, and then I'm going to solve for x. And I get x equals 4. And again, if they wanted me to give them the actual length, I'd have to plug x back in. And then our last example, so here we have 3 parallel lines and we have a transversal. And if we notice, we are given that AC is congruent to CE. So that tells me that BD is congruent to DF. And congruent meaning same. So if DF is 3, then BD also has to be 3. And BF would be the whole thing, so I'm going to have to put them together. And so I get 3 plus 3, which equals 6.